In this lesson, we're going to factor trinomials of the form ax squared plus bx plus c. And in this case, we're going to deal with an a that is not 1. So we're going to have a leading coefficient or a quadratic coefficient of something other than 1, which is going to be a little more challenging than my factoring trinomials where a equals 1. There's two different methods we can use. We can use what we call guess and check, where I'm going to figure out by undoing basically the foiling, how to come up with the factors. And then we have another method called the make it 4 terms and use factor by grouping. Now in this method it's more a step-by-step method, so some people like it because they don't tend to like to do things in their head. I'm going to do several examples of our factoring these trinomials that are the more difficult type. I think the more examples I do, the more you'll understand how this works. So when I look at this first example, I have a 3y squared. So when I set up my parentheses to try to factor that, I can't just put y and y like we would if it was just a plain y squared. But I do know that I'm going to have a 3y and a y because I don't have another option. Okay, 3y times y will give me the 3y squared. I can't write any other number in front of my y's to give me the 3 for the y squared. Now, the hard part is coming up with the second part, okay? Because what I need to have happen is I need to have these two multiply to give me -5, and then when I multiply this times this and this times this, and add them, I need to get the -2y. So the problem here is I have a 3y here, not just a plain 1y and a 1y here. So this 3y is going to be multiplied by whatever I have here to be that outside term that will then be added to this one to give me the -2y. So the way I do this is I use my method that I used in the factoring the trinomials with the 1x squared, but in this case I'm going to find two numbers that multiply to give me the 3 times the -5. So it's always the first times the last when it's in descending order, so that's going to give me -15, and add to give me -2. So I still want to add to give me that -2. I'm going to come up with these two numbers, and in this case I have 1, 15, and I can have 3 and 5, because when I multiply to give me a -15 and I add to give me a -2, I'm going to need, in this case, one negative and one positive, with my negative being the larger of the two. So this is going to be a -5 and a +3 are my two numbers. Now, I can't just write these two numbers into my factored form like I could if I had a y and a y. So what I'm going to have to do is I'm going to have to think about this, and I'm going to have to figure out this times this needs to give me one of those two numbers. Now, 3y times anything, or any nice number, is not going to give you a -5. So I'm going to have a +1 here so that I get 3y here. And then this times this needs to give me the -5. So I have the -5y here, which will add to give me the -2y. And you'll notice that -5 times 1 is going to multiply to give me the -5. So this is the guess and check method. Okay? You'll notice I'm figuring out what works by thinking backwards. If I foiled this, would I get what I started with? The second method is to make it 4 terms. The first part of this is the same. I still want to come up with these two numbers. But what I'm going to do is I'm going to take this problem over here, and I'm going to write it as 4 terms. I have 3y squared, and instead of a -2y, I'm going to write plus 3y minus 5y minus 5. So you can see that this part right here, the 3y minus 5y, is the same as -2y. I just wrote it as 2 terms so that I now have 4 terms, and with 4 terms I can factor by grouping, and that's going to give me a 3y y plus 1, and I can factor out a -5, and I get y plus 1, and so I have the y plus 1 in common, so I'm going to be able to factor this as y plus 1, 3y minus 5. Same factors, they're out of order, but because multiplication is commutative, that answer is going to be just as good as my first answer. Okay, so you can see it's a little more step by step. Once I come up with these two numbers, I just replace them in here for my 2y, -2y. I now have 4 terms. I'm going to follow my factor by grouping method. which if you don't remember that method, you can look at my last video that has the factor by grouping. In this next example, I'm going to use the same process. What multiplies to give me 60 and adds to give me 19. So I try to come up with these numbers: 160, 230, 320, 415, and I'm dealing with two positives. In order to give me a multiply to give me 60, add to give me 19, I'm going to use my guess and check method first. So in this case, because I have a 5n squared, I'm going to have to write 5n and then n. My two numbers I came up with were 4 and 15. So when I FOIL this out, these two need to multiply to give me either 4n or 15n, and these two are going to give me the other one. Well, I'm not going to get a 4 with a nice number here, so this is going to be a plus 3. So I get my 15n, and then this one's going to have to be a plus 4 to give me the 4n. And you can see clearly that 4 times 3 will also give me the 12, so it works. Okay. The step-by-step method, I'm going to take this and write 5n squared plus 4n plus 15n plus 12. I'm going to factor it by grouping, which gives me an n, 5n plus 4 plus 3, 5n plus 4. Then I can take out the 5n plus 4, and I'm left with n plus 3, and I get the exact same answer. In this next example, I'm going to look at it, and you can see once again I have a 6k squared instead of just a plain k squared. However, when you look at all three of these terms, I do have a GCF other than 1. I can actually factor out, in this case, a 3. And what that's going to do is I'm still going to have a 2k squared, but it is going to make it a little bit easier to go through this process. Okay, because I won't have the 6, I'll only have a 2. So I do know with my guess and check method that I have a 2k and I'm going to have a k. Okay, I have no other option here. So what multiplies to give me -8 and adds to give me 7? Okay, I'm dealing with multiply to give me a negative, so I am going to have a 1 positive and 1 negative, with my positive being the larger one. So I have 1 and 8, 2 and 4. If you look at this, I'm going to have a -1 and a +8. So they multiply to give me -8 and +7. So when I figure out what has to go here, I need either a 8 or a -1. So this is going to have to be the 8, and this one's going to have to be the -1. So here I get 8k, and here I get -1k, which is going to give me the 7k, and the -1 times the 4 gives me my -4. Okay, so my factored form here is this one. Now I could have done this without taking out the GCF. I would have had to deal with larger numbers. And then at the end, when I looked at my factors, I would have seen that I could have taken out some number from the start, and I would take out that GCF at the end. Now when I do this using the second method, the factor by grouping, I need to be careful, because when I rewrite this part in parentheses, I'm going to have 2k squared plus 8k minus 1k minus 4. And what can get a little tricky is this 3 kind of gets in the way when I do my factor by grouping. So what I tell some people is that wherever you're going to write the answer, I'm going to put my 3, and then I'm going to put my parentheses. So I don't want to forget the 3, but I'm going to ignore it until I get my answer. So at this part, I'm just going to go through the process of factor by grouping, and I'll take out a 2k and get a k plus 4. Here I can take out a -1, and I get k plus 4. And so what I'm going to have here is k plus 4 and 2k minus 1. And you'll see that that 3 is in the answer. I'm just going to ignore it for a little while so that it doesn't get caught up in my factoring by grouping. Now in this last example here, I have two variables. I have the p squared and the q squared. We did this with the trinomials where I just had like a 1, my a was 1, but now I'm going to do this in in this particular problem. It's good to learn how to do this with the second method especially, so you make sure your middle terms are put in there correctly. So I'm going to do the same thing. Multiply to equal 24, add to give me negative 11. So I have 1, 24, 2, 12, 3, 8, and I multiply to give me positive, add to give me negative, so these are going to be both negative. I have negative 3 and negative 8. So when I do my guess and check method, I do have to be careful for this one because I have a 4p squared, which means I could have 4p, or I could have 2p and 2p. So in order to figure out what I need to use there, I'm going to look at what I have over here. I have a negative 3 and a negative 8. So if I tried to use 2p and 2p, there's no way to get negative 3 nicely. So in that case, I'm going to use the 4p and p, because I'm going to be able to set this one up as a negative 2 and this one up as a negative 3. But because I have this q over here, I'm going to have to add a q to both of those terms. So when I multiply the negative 3q times the negative 2q, I will get the 6q squared. And my 4p times negative 2q is going to give me negative 8pq. And the negative 3q times p will give me the negative 3pq, which will add to give me the negative 11pq. So this is going to be my factored form. Now, with the second method, where I make it 4 terms, I'm going to have to rewrite my middle term. But my middle term has pq in it, so I'm going to write negative 3pq, negative 8pq, plus 6q squared. I need to make sure that I have the same variables in my middle terms. These have to have the pq, just like up here I had k, these have to have k in here. Okay? So now when I factor by grouping, it's going to work out. I'm going to take out a p, I have 4p minus 3q. Here I can take out a negative 2q, and I have 4p minus 3q. And so I end up with the 4p minus 3q times p minus 2q. Okay. A couple things to remember as you're going through this factoring. This is the hardest type of factoring. Make sure you take out the GCF first. It'll make it easier. As far as the numbers, you'll have smaller numbers. You're going to have to take it out at the end anyway, so you might as well do it at first. When you find the two numbers, you want to find the two numbers that multiply to give you a certain number. Make sure you take the first times the last term. Where we didn't have to do that if I had just plain x squared, you do when you have a number other than 1 for that leading coefficient. So make sure you do take the first times the last. And then the two numbers that you come up with, you cannot just place them in the factors like we could with the easy x squared trinomials. You need to make sure those are the two numbers you get when you multiply the outside and the inside. Okay, so you're going to have to use the two factors to come up with those numbers. Aren't just going to be placed directly in there. And then when using the 4-term method, make sure your middle term has the same variable as the middle term in the original problem. So those two terms that you're making it 4 terms with, you look at the middle term of the original problem and make sure that they're the same. And finally, always when you're factoring, check your answer by multiplying your factors. Make sure you have the correct signs. Make sure you're getting what you started with when you do multiply that out.